Okay, so we will be looking at the unit review or the final exam review for Unit K. And I'm going to get my calculator handy, so we're looking at that. So the first group here of 6 questions is just looking at if it's a permutation or a combination. So the first question, a group of 16 people need to take an elevator to the top floor. They go in groups of 8, and they are deciding who will take the elevator on its second trip. So they will go in groups of 8. Right, so 2 groups. So what we need to do is we're going to pick, if there are 2 groups of 8, then we're going to pick how many people are going to go into the second group. Now, you have to ask yourself, for permutation or combination, does the order matter? Well, if we said the first person gets to push the buttons, the second person has to sit down, or I don't know, weird stuff like that, if we were assigning roles to each person picked, the order would matter. But here the order does not matter. So this is going to be, of the 16, we are choosing 8. And so this is 16 combinations of 8. So using our calculator, we can do 16 going over to probability, combination 8. So we get 12, 8, 70. Excuse me. So that many possibilities, and it is a combination. All right, so for number 2, 260 athletes are at a meeting. They each give a Valentine's Day card to everybody else. So how many cards were given? So yeah, so this is a little bit tricky in thinking about if order matters or not. So you're giving a card to each person. So, if you have 2 people, person A and person B, if you give a card to person A and then a card to person B, is that the same as giving the card to person B and then person A? Well, no, because they're different cards. So this is a weird one. This is a permutation. So of the 260 athletes, how many are you giving a card to? Well, we're giving a card to 259 people. No, that doesn't make sense. 260 athletes at a meeting. Yeah. So really it's pathetic. No. Yeah, so we want to be careful. If you just saw my calculator, it's telling me overflow. It's too much going on there. So this is 260 permutation 259, which, if we think about it, this is n factorial over n minus r factorial, which is 260 factorial over yeah, no, that's too big. Well, basically, this is going to be 260 times 259, right? So from each person, you're going to give others. So we get this. That's a bad problem. Don't worry about number 2 for the final exam. That's an ugly one. Something like number 3 is a little bit easier, right? A little bit better because we have a student body of 275 students, and we're going to select a president and a vice president. Order matters because whoever we pick first or second, gets a different role. So out of the 270 students, we're picking 2. So this is a permutation. So out of the 275, we are going to use a permutation to select 2. And so we get 75, 350. Yeah, that's the type of question to know for the final exam. And number 4 here, notice we have a race of 20 people, and we want to find the top 8 finishers. Do we care who comes first and who comes 8th? No, because they both advance. So the order does not matter. So this is 20 choose 8. This is a combination. So if we do that into the calculator, 20 choose 8, then we end up with a rather big number, 125,970 possible ways. Number 5, we had a question like this similar on that test, right? You have a combination for 5 digits, and you want to use these numbers. So 6, 2, 4, 1, 3. So there are 5 separate digits there. You don't care what order they're in. Guess what? The lock does. So this is actually a permutation. So of these 5 different digits, we're going to select 5. So this is 5. Permutation 5, and so we get that is equal to 120. So there's 120 possible ways there. Number 6, we have homework in 5 subjects. Wants to know the order to complete them in. It doesn't matter the order. The order does matter because that's what he's trying to figure out. So we have the 5 subjects, how many we're picking. So that's actually the same as the previous question, 120. Right, and then for the next set of questions, these are mutually exclusive. So that means that probability of A and B is equal to 0. So the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B, which in these cases is just 0. So I can actually use this for both of these problems. And then so this is 9/10 is equal to 2/5 plus probability of B. So using common denominator, this is 4/10, so probability B is 9/10 minus 4/10, which is 5/10 or 1/2. And then for 8, we again have 9/10 is equal to 9/20 plus probability of B. This over here is going to be 18/20, so if you subtract 9/20, we will have 9/20 for probability of B. So simple equations there, just know the formulas. Here these are not mutually exclusive, so if we take this same formula, now probability of A and B does not equal 0, so we have to include that into our equation. So we get probability of A or B is 22 over 25 is equal to 3/5. Whoops, this should be B. That should be probability B. Okay, fix the formula. So probability A plus 7/10 minus probability of A and B, which is what we are looking for. So common denominator says that this is 6/10. So we get 13/10, which we're going to need a common denominator for. So this is 22 over 25, which is the same as 44/50. And this over here is going to be 13/10. So if I multiply that by 5, I'm going to have 65/50, and this is equal to negative probability of A and B. So 44 minus 65 is going to be 21. Yeah, negative 21. So that means that the probability of A and B is a positive 21/50, because we have negative probability equals negative 21, so positive probability equals positive 21. And then the same setup for the next question, where we have 33/40 is equal to 13/20 plus 1/2, which I'm just going to write as 10/20, minus probability of A and B. So this is 23/20, which is 46/40. So we have 33/40 minus 46/40 is equal to that negative probability. And so that's negative 13. So we get, again, probability of A and B is equal to a positive 13/40. These are independent, meaning we could just multiply them. So probability of A and B is equal to the probability of A times the probability of B for both of these. So this is equal to 1/5 times 7/20, which is 7/100. And same setup over here. This is going to be 3/5 times 9/20, which is 27/100. And those are the correct answers. Now the next set of questions here are just about these cards. So a card is drawn from an ordinary deck of 52 cards. We want to find the probability that the card is an ace or a heart. So we can actually use that same setup as before, that same equation that we have here. And we actually have, so we can assign the probability of it being an ace as probability of event A, and the probability we get an ace from the deck is 1/4. And the probability of event B, which we can say is a heart, is 1/13. So what's the probability we get A or B? That's 1/4 plus, actually I can use my common denominator, so 1/4 is 13/52 plus 4/52. That's the probability we get a heart. Yeah, that's, sorry, I got this. These are actually the right probabilities, but the probability of picking an ace is 1/13, and the probability of getting a heart is 1/4. I got those probabilities mixed up, so then these are mixed up. So then we have 4/52 plus 13/52 minus the probability I get a heart and an ace, which is 1/52, because there's one ace of hearts. So this is 17 over 52 minus 1, which is 16 over 52, which we can reduce to 8 over 26, or 4 over 13. What about the probability we have a diamond, a club, or a king? So rather than using this complicated formula, I don't want to take the time to go through that. Well, we could think about it that the probability we get a diamond is 1 out of 4. Probability we get a club is 1 out of 4, and the probability we get a king is 4 over 52, or 1 over 13. So this is 13 over 52, 13 over 52, and then 13 over 52. Now the probability that we have a king and a club is, so we can add these all together. So 13 over 52 plus 13 over 52 plus, oops, plus 4 over 52. But then we have to subtract the probability to get a king and a diamond, which is 1 out of 52, minus the probability to get a king and a club, which is 1 over 52, minus the probability we get a diamond and a club, which is 0 over 52. So then this is 26, so 30, 29, 28 over 52, which we can divide by 2 to get 14 over 26, which we can divide by 2 again to get 7 over 13. But I kind of just wanted to skip over that one right now, just because I'm not going to give you one where I have these 3 events. That's kind of, anything you have to do on the final exam you can use for this with this formula. So if you have a difficult time thinking about this conceptually, don't worry too much about it. And then for 3, 2 cards, and we are replacing them. So this means I pick a card and put it back in the deck. So what's the probability that that means we can just multiply straight probabilities. So what's the probability the first card is an ace? Well, that's 1 out of 4. No, sorry. That's 13 out of 52. No, did that again. 1 out of 13. I'm mixing these up. Or 4 out of 52. Right, 4 aces in the deck. Times the second card is black. Well, half the deck is black, so that's 26 over 52. So we can reduce this to say this is 1 over 13 times 1/2. So this is 1 over 26. Yep. And then both cards are spades. So that's a 1/4 probability times a 1/4 probability, which is a 1 over 16th probability. And then neither card has a value 2, 3, 4, or 5. Well, there are 13 cards minus these 4, so that means that there's 9 out of 13 remaining, right? So 6, 7, 8, 9, 10, Jack, Queen, King. That's 8. 8, 9, 10, 11, 12. Oh, then the ace. Whoops. That's 9. So 9 over 13 times... Oh, times 9 over 13. So it's just squared, so it's 81 over 169. And then at least one card is in ace. So so the probability we get an ace is 1 over 13. And then I mean, the next one could just be anything. It could be 13 over 13, 52 over 52. So we end up just getting 1 over 13. And then the next one, so the first card is an ace, or the second card is black. So this, I'm going to use this magical formula again. So we're defining the probability that we get an ace as probability event A. So that is 1 over 13 plus the probability the card is black, which is 1 over 2, minus the probability of A and B. So we get a black ace, which is, I'm just going to write that as 2 over 52 because there's the ace of clubs and the ace of spades. So this is 4 over 52 plus 26 over 52 minus 2 over 52. So we get 30. And then 28 over 52. I think that was a fraction I had to reduce earlier. Yeah, it's 7 over 13. And so that's it. I'm going to make sure the problems on your final exam look similar to this. Not like this 1C here where you have the multiple events. Watch out for replacement and just watch out for your formulas, but you should be able to use these formulas or multiply when the events are independent.